In this lesson, I'll show you several examples on how to find the derivative of sine functions. What you need to know to be successful with all of these questions is the following. That if you take the derivative of sine, let's say sine u with respect to x, all you do is you write down cosine with what u is equal to, and then you take the derivative of u as if it were a function. With that being said, in question 1, they want us to find the derivative of y is equal to sine 3x. We are finding the derivative with respect to y. So starting on the left side, y becomes dy over dx. And on the right side, this part represents my u. And I know that the derivative of sine is cosine u, or cosine, in my case, 3x. The derivative of 3x is easy. Use the power rule. It becomes simply 3. So our final answer is dy over dx is equal to 3 cosine 3x. That's all it takes. Let's move on to question B. Here we have y is equal to sine x to the power of 3 plus 2x to the power of 2. This time our u, let's call this our u, is slightly more complicated. It contains two terms, but the process is the same. We write down dy over dx is equal to cosine, in this part, x to the power of 3 plus 2x to the power of 2, times, now the derivative of this, the derivative of x to the power of 3 is 3x to the power of 2. I subtracted the 3 by 1, giving me 2, and then I brought the 3 down. And we'll place a bracket because this is a binomial. Unlike the first question, this was a single term, so this one you should put in brackets. Plus, the derivative of this is 2 times 2, which is 4, and 2 minus 1 is 1, and that's it. This represents the derivative of question B. Finally, in question C, we have y is equal to sine to the power of 3x, which means y is equal to sine x to the power of 3. To find the derivative here, I'll take this 3 and multiply it to sine x. I'm sort of using the power rule here. Dy over dx is equal to 3 sine x to the power of 2. And now I need to find the derivative of sine x. The derivative of sine x, we all know, is cosine x. So technically, we use the chain rule. Let's move on to question 2. They want us to find the slope of the tangent to the curve y is equal to x to the power of 2 minus sine squared x when x is equal to 2. So let's find the derivative and then substitute x is equal to 2 into the derivative, and that will give us the slope at exactly x is equal to 2 for the original function. So we have y is equal to, the derivative of this is 2x. I'll use the chain rule again, kind of like how I did in part C. Minus 2, I brought this 2 down, sine x, now the derivative of sine x, which is cosine x. My next step is to set x equal to 2. This becomes 4 minus 2 sine at 2 times cosine at 2. Now using our calculator, make sure that your calculator is in radians. Mine is not, so I'll click Shift Mode 4. Now it's in radians. 4 minus 2 sine at 2 times cosine at 2 gives us 4.75. So y prime at 2 is 4.75. That's the rate of change at x is equal to 2 for our original function. And so there you have it. 4 examples on how to find the derivative of sine functions.